This is a motion problem. It's about driving speed. Craig drives 20 kilometers per hour faster than Marilyn. In the same time that Marilyn drives 225 kilometers, Craig drives 325 kilometers. Find the speed of each car. Well, let's begin by familiarizing ourselves with the problem. Now, we need to assign some variable names to the speeds that we're looking for. And since Craig's speed is described in terms of Marilyn's speed, let's let R be Marilyn's speed. And this is going to be in kilometers per hour. Then, since Craig drives 20 kilometers per hour faster, we can say that R plus 20 is going to be Craig's speed. Now, let's just sketch out a little table and try to organize this information. We'll draw a table. We'll put distance, speed, and time across the top. And we're going to have two rows. One will pertain to Marilyn's speed and one to Craig's. So this will represent Marilyn, and this will represent Craig. Now, we're told that Marilyn travels 225 kilometers in the same time that Craig travels 325 kilometers. We just assigned the variable R to Marilyn's speed and R plus 20 to Craig's speed. And they do this traveling in the same amount of time, so we can represent each time by the letter T because the times are the same. Now, to translate to an equation, we'll use these two rows of the table. We know that distance is equal to speed times time. So the first row of the table tells us that 225 is equal to R times T. And the second row of the table tells us that that distance, 325, is equal to the speed, R plus 20, times T. Now, since the times are the same, if we would solve each of these equations for T, then we could set them equal to each other, and we'd have an equation in one variable that we can solve. Since 225 is equal to R times T, if we divide both sides by R, we get 225 over R is equal to T. And since 325 is equal to R plus 20 times T, if we divide both sides by R plus 20, we get 325 over R plus 20 is equal to T. And again, we said the times are the same. So that tells us that we can write the equation 225 over R equals 325 over R plus 20. And this is the equation that we want to solve. Let's go to the third step of the process and solve it. We have a rational equation. We want to clear the fractions, and we'll multiply by the least common multiple of the denominators to do that. And the least common multiple is just the product of these two denominators, R times R plus 20. So we'll multiply both sides of the equation by R times R plus 20. R times R plus 20 times 325 over R plus 20. Now on the left-hand side, the R's cancel, and I have 225 times the quantity R plus 20. And on the right-hand side, the R plus 20's cancel, and I have 325 R. I'll remove the parentheses here. We have 225 R plus 4,500 is equal to 325 R. I'll subtract 225 R on both sides, and we have 4,500 equals 100 R. and then dividing both sides by 100, we have 45 equals r. So r would be Marilyn's speed, and we can say if r equals 45, then r plus 20 is 45 plus 20, or 65, and that would be Craig's speed. And now let's check and see if these speeds work in the original problem as it was stated. The fourth step in the process is to check the solution in the original problem. Now let's think about what we have. We've said that Marilyn's speed was 45 kilometers per hour, and Craig was traveling 65 kilometers per hour. Now, if Marilyn traveled 225 kilometers at 45 kilometers per hour, the time that it would take her would be the distance divided by her speed, and that would be 5 hours. And if Craig travels 325 kilometers at 65 kilometers per hour, the time it takes him to do this is 325 divided by 65. And that's also 5 hours. So the times are the same, and that tells us then that the answer checks. And we can state the answer. The speed of Marilyn's car is 45 kilometers per hour, and the speed of Craig's car is 65 kilometers per hour.